Okay, so we're solving two-step equation story problems. So let's title this up. Two-step equation story problems, or word problems, sometimes they're called. And the way we use, it is 51. Okay, so this is page 52 for me. The way we use our algebra skills in the real world is in context. That means it's related to something, a situation, right? So we're going to start basic, and then we'll build it up. This school year and definitely next school year. Okay. So, yeah. So what we're going to do is the following. Let's talk about some steps that we're going to do. So we're just gonna write down a word problem, and I'm gonna model for you the steps we need to follow on this problem and on the problems we're going to be doing in our assignment. It's a CAMI assignment, okay, and we'll be doing those. So if you're following at home, there's two parts to this video. The notes part, it's going to be short, and then the part where we actually work on the assignment together, okay? So here we go. Let's write down a problem that we're going to solve. Okay, so write this down. Uber charges $1.75 plus, it's not never just $1.75, a fee of, let's say, 75 cents per mile. Okay. Let's say the total cost for a trip was $10.75. Okay. How many miles was the trip? Question mark. Okay, so I'll give you a moment to finish writing that down. And I'm not looking for a answer. Don't just spit out an answer. I'm going to show you the process we're going to follow. Okay? Like I said, many of these questions you may even be able to do in your head, right? Because maybe you already have that thought process that we're going to show on paper. And that's great. You're ahead of the game. But I need you to put that thought process in the form of an equation on paper. Okay? You need to show me that you can do that. So let me just go over kind of the steps. So step number one, I'm just going to read the problem more than once. And we're reading for understanding. understanding the story, the situation. Okay? And as we're reading, identify key details. Okay? So why don't we do that? So let's see, we need to know that Uber charges $1.75 plus a fee of 75 cents per mile. That's important. Anything else we want to know? Yes, Kayla.
The total cost of the trip?
Yeah. Total cost was $10.75. Now, something that I'm going to say, understand what needs to be answered. Okay? So in our case, here, what we need to answer, kind of gravitate to the question, guys. The question says, how many miles was the trip? That's what we need to answer. How many miles was the trip? Okay. Now here's the part where we start getting into some algebra, okay? We're going to assign a variable. Okay, so let's do that now. Let's see, what are we going to see here? I'm going to just well, before we do that, we need to assign a variable. The question says, how many miles was the trip? M, and what does M represent though? Miles. So let's say M equals miles for the trip.
Now do we make the equation?
Let's write that down though over here. Make an equation. And finally, if we have an equation, what are we going to do with it? Solve it, yeah. And then usually that leads to our answer. So then just state the answer. Gabriel, you wanted to add something?
Can I say what the equation could be?
Of course, hold on, give me a second. So I'm going to just bubble that off to the side. So tell me, what could the equation be?
Do we have to add dollars or can it just be like regular numbers?
I'll leave it up to you. Well, how are you? What are you thinking? Either way is correct, I think.
I would say 1.75 plus 0.75 m equals 10.75.
Okay. So 1.75. So we're going to leave it in decimal form. I'm perfectly okay. Plus, you said 0.75 m.
Yes.
equals, what did you say?
1075.
So we left it in dollar form, not in cent form. And that's perfectly okay. Now, if you didn't want to deal with the decimals because they just don't make you comfortable, multiply everything by 100, the decimals move out, and then you'd have 175 plus 75m equals 1075. Yeah, and that would be in cents. But you'd get the right answer either way. Okay? So we're going about it with cents, which means decimals. Are we okay with that? Okay. So now it's just an equation. Does it make sense though? Yeah, it's $1.75 plus the 75 cents per mile. So we have to multiply it times however many miles, and that's what M is the $10.75. That's the total. Okay. So solving time. What I need to do is get rid of $1.75. Let's cancel that out. And that gives us 0.75 M equals 9. Yeah.
Or do we have the 0.00?
Why not? Why not? 9.00. Okay. Let's get rid of that 75. It's being multiplied. Guess what I have to do? Divide. So write this down. So you can, at this point, if you want to, you can get a calculator, or you could think of terms of money.
12?
Is it 12? How many 75 cents?
12. It'll be divided by 3/4. And then
Yeah. So the answer is
12. M equals 12.
okay. Now the question is, what does that 12 represent?
The miles.
M, this is why we go back and define miles for the trip, and it was 12. So we would write, how many miles was the trip? The trip was 12 miles. Boom. Okay. And that is what we were hunting for. So really, it's just read through the problem carefully, know your details in the problem, know what you have to answer, use that question part, the part you have to answer, to set up a variable. Use the variable in your equation. You get the equation from the context, and then solve it. And then usually whatever the variable represents is your answer. Okay? So any questions on that? Okay. So that's the notes part. We're going to go ahead and move on to the assignment. So I'm going to turn this off. Is anyone still writing? Okay, so this is the second part of the video, and we're going to go ahead and look at a few of the problems in the assignment. By the way, for the assignment to get full credit, you have to do 1 through 10. 1 through 10. But if you do 11 through 14, you will get extra credit. I'll throw in some extra credit for that. Okay? So it's only 1 through 10 that's mandatory. Okay. So let's model this. I'm going to zoom in kind of big. Maybe even bigger than that. 300. Let's see how that looks. Okay, I like that. So here we are, problem number 1. We're all doing this together, okay? We'll do a couple of these together. Yes. Please.
331 students went on a field trip. 6 buses were filled, and 7 students traveled in cars. How many students were in each bus?
Okay. How many students were in each bus? So we should probably get some important information. I'm going to go to markup. I'm going to make sure I'm on the box highlighter. I'm going to pick something. So I have this fact here. 331 students went on a field trip. What's another fact I'm going to need?
6 buses were filled, 7 students traveled in cars.
6 buses were filled. And then 7 traveled basically separately in cars. And then I'll change the color. This is what we need to answer. How many students were in each bus? So if I want to start by defining a variable, I'm going to call it B. Guess what B represents? Yes.
Do you have to define, like, do you have to define?
Yes. Yeah, you have to define a variable on these. So B is going to represent what?
Cars.
Go back to the question. This is why we define the variable.
Is it like students? How many students went into each bus?
Yes.
6.
Just go back to your question, and that's what the variable is going to represent in 99% of the cases. How many students were in each bus? B represents number of students in each bus. That's what we have to answer, and luckily for us, that's what we. So let's come up with an equation now. That comes from the context. So let's see, we had 331 students total. 6 buses were filled and 7 traveled in cars. Zach, did you have something?
Can we just do 331 minus 7?
No, I want an equation like the ones we've been solving in 2 steps. I mean, you can get it from this information, yes. You tell.
31 equals 7 plus 6b.
Yeah. Let me write it with the variable on the on the left side. So you could do 6 times b, 6 buses times the number of people in the bus, plus the 7 that traveled on their own equals 331. I just like the variable on the left side. So it's basically, Gabriel, everything you said, right? But with the variable on the left. All right. Well, now we got to solve this. Let's see. We would do what? Sometimes I find it easier to just use the drawing tool. If you want to type, you can. Ooh, but it helps if the variable, I'm sorry. It helps if, let me get rid of this. Well, now I just wasted more time doing that. Let me just type it now at this point. -7. And over here, we take away 7. Right? And let's see what that gives us. I'm going to go back to blue and say 6b equals, what's 331 minus 7? And if we divide that, I just want to show you all your options for showing your work here. If I divide by 6, it should tell me how many people were on each bus. Basically, whatever 324 divided by 6 is. 54. We have our answer. Okay, so that's the thing. I want us to set up equations. Okay. I want you to practice getting in that mode of thinking. Okay. Any questions? I want to go to number 4. Number 4 is a little different. So can we all do number 4 together? Read the problem, see if you can get a handle on it. It's a little different, but once we break it down, it will actually be pretty easy. So problem number 4, it says the sum of 3 consecutive even numbers is 48. What are the smallest? Shouldn't it be what is the smallest of these numbers? Yeah, but they're asking for one number, right? What is the smallest? There's only one smallest. I mean, don't get me wrong, grammar is not my forte, but I think I can say that. Okay. Wow, how to answer this? Well, we know the question. So what does our variable represent in this particular problem? The smallest number. So I'm going to start with that. I'm just going to type in here n equals the smallest number. We also know that it's an even number, right? Maybe I should add that. Now, I want us to think a little bit because that's going to help us set up equations. Okay. Zach, I see your hand. You have
if we could find the smallest number, couldn't we like just do 48 divided by 3?
Sort of. Well, eventually that's going to be done. But I want us to think of it in terms of we don't know what the smallest number is at this point. So we're calling it n, right? We're calling that smallest number n. But let's experiment a little bit with even numbers. Say the number is 2. That's our smallest number. How do I get to the next even number? What's the next even number from 2?
4.
So that was 2 plus 2, right? Right? How do I get to the next? So this is 4, right? Started off with 2. 2 plus 2 gave us that. How do I go from 2 to the next one after that? 2 plus what? This number would be 6, would be the next even number. 2 plus what? 4. Say I wanted the next one after that, which would be 8. 2 plus what?
6.
Okay, you see the pattern. So there we have the 3 even consecutive even numbers. We have the original one. I could call it n, since I don't know it. I have the next one, n plus 2. I have the next one after that, n plus 4. And I don't need it for our case, but n plus 6 would be the one after that. So these are my numbers, n n plus 2 would be the next one, n plus 4 would be the next one, and then so on and so forth. Okay? So we're going to use that kind of logic to set up an equation because we don't know what our smallest number is, but we're calling it n. So we have our smallest number, n, and it says sum, so we have to add. What are we going to add to that? The next even number, which is what? n plus 2. That's the next even number. And then it says 3 of them, so I have to add one more. What's the next even number after that? N plus 4. There's a sum of 3 consecutive even numbers. And it has to equal how much? 48. Okay. Well, we've done this before. In fact, do we have to distribute? No, we could just bring them out. N plus 2 plus n plus 4 equals 48. So this is technically more of a multi-step problem, but that's okay. That's where we're going anyways. Let's combine our terms. Combine your n's. What do we get? 3n. So eventually, yes, Zach, we are going to divide by 3. And then add your 2 and your 4, you get 6. Oops. And that equals 48. Okay. So solve this equation for n, and it should tell you what the smallest even number is. Okay, I'll leave it for you to finish. But I figured I'd help you with that one because we never talked about consecutive even numbers. Yes?
Can I see the answer?
Well, you can share it with us.
Isn't it 14, like n?
Yeah, eventually. Yeah, at this point, you can even do mental math to do it, but I want you to practice setting up those equations. Okay? This one was tricky. All right? So I'm going to leave you to continue working on this. Remember, just do up to number 10, but if you are motivated, you want to do the rest of them for some extra credit, you can. You just have to do them in this format. Tell me what the variable represents, set up an equation, solve it, state the answer.
Would that be the same equation for number 3?
Possibly. Oh, yeah. So I helped you with one, and now you can do the other.